morning. I'm going to be doing a micro review today of the Korad 6003P. That is to say up to 60 volts and up to 3 amps programmable DC power supply. I received this yesterday, the day before Christmas, from Amazon at a cost of 145 Canadian plus taxes, so I certainly can't beat the price there. And I have run this unit overnight to charge a 12 volt lead acid battery just to make sure that no magic smoke disappeared. So today what we're actually going to be doing is looking for the kind of transients and noise that you can expect. This is a very simple load circuit under test, or 100 ohm power resistor. And alright, so I've got an oscilloscope here to take a look at what happens. Let's see what happens when we turn it on. So on we go. I'm going to go to a 14 volt load. Now, you're not actually seeing any output here because of course the output enable isn't on. However, if I take a look at my scope here, I can see that there has actually been a transient when I turned the unit on. Well, that's as you can see, it's basically about a 8.6 volt transient from the top peak to the bottom peak. Well, that's kind of disturbing, but it does mean that you will want to turn the unit on before you connect it to your circuit under test. Now, that being said, I've reset the scope. You're not seeing anything because it hasn't triggered it before I turn on the output enable button. So let's just go ahead and do that. And right away you can see that it jumps up to 140 milliamps of current, which is what you'd expect on a 100 ohm load. The voltmeter is reading 13.97 volts, which is consistent with the 14 reported by the power supply. And if we take a look at what we see on the output, it goes into a nice clean 14.8 volts peak to peak, but that's including noise in here. And you don't see any transient overshoot, so that's a good sign. It means that once the once the power supply has been turned on, you connect the circuit under test, then turn on the output enable button. You're not going to blow your circuit, at least on the overshoot. So I'm going to do the same thing but in reverse. I'm going to turn off the output and enable and do a trigger to see if we're getting any spikes right before turning off the output enable. So I'm going to obviously have to change the trigger slightly, and we will trigger now on a negative slope, and let's see what we get. Turn off the output enable button, and there we go. So pretty clean decay here. There's no transient, of course, and again, that's a good sign. Now, the other item here is how much noise is on these rails. So that's a little more disturbing. You can see even at this 5 volts per division resolution that there does appear to be a fair bit of noise. So let's take a look at, let's turn the load back on first of all, and let's take a look at the kind of noise that we will see. So in this case, I'm going to just switch this to a AC coupling and set the trigger to be a mode of auto level. Okay, and we'll just turn down the volts per division here. So here we go. Now, isn't that interesting? So that's what you're seeing in AC coupling on the output, and what you're seeing basically is 140 millivolts peak to peak on those little micro transients. Not really all that good. In fact, I'd say that's pretty poor, right? That is representing, well, I guess it's 140 millivolts on top of 14 volts right? That is a significant degree of noise. And just to put some proof into the pudding, I'm going to drop this down to a more typical, if you were going to be working on hobby electronics, 3.3 volt output. We'll turn on the output enable again. And again, you're still reading these transients here. If I go to a accumulate mode, you'll be able to see it as it tends to fuzz up over time. We're acquiring on peak detect, right? But even if I acquire on sample, of course, you know, you're getting accumulated noise. And again, well, 120 millivolts peak to peak on the 3.3 volt output, which, well, might be within your tolerances, but definitely you're going to want your decoupling capacitors on your circuit. So a little more noise than I would have been hoping for, but not horrible. Considering what you're paying for this unit, you know, really the only drawbacks I've seen are A, this noise, and B, the transients when you first turn the unit on, but before you activate the output and enable. So if you can live with that, as I said, you can't really beat the price. I'd rate this a solid C.